What do you understand by time complexity? Anyone?
Time is taken to execute that particular piece of code.
I'm not exactly correct, but okay, anyone else?
Yeah, that much only I can say.
But for to denote those, I mean, to denote that time taken, we have some standards we follow to measure the complexity of the time. So I think the time complexity can represent in order of big O notation and all.
Yeah, okay. So basically, there are two different things like time complexity is different thing and actual execution time, that is a different thing. Uh, Time complexity we use only for analyzing the like how much time it is taking related to what the input data is. We are analyzing the time, relative time, which is not the actual execution time. So, like in actual execution time, it will calculate for average step how much time it is taking, then it will show the output. But for time complexity, it is only taking into account like the number of uh, like for this
Iterations.
for this if this is a for loop, it will only calculate like for this piece of code how many times they are being executed. Number of it is related to the number of times that piece of code is executed.
I have a question. Like, what is the practical application of time complexity? Like, I know
Okay,
it is used to improve writing code, but what are its applications?
okay. So this like only one application is there like to when we design any algorithms or any application it will be write any solution to any problem,
Hmm.
then we'll need to see how much data we are processing or how much space we have. All of these things we need to take into account. According to that, we'll only design any algorithm. So for that, we can roughly calculate how much time it will take to run. So uh, like this is only the basic and one use case of this.
Okay.
Like there are three. We can denote time complexity in three ways. Or is it big O, omega, and theta. Big O is for denoting the worst time case, like the algorithm will take the first time to execute the piece of code. Omega is best time case and theta is average time case. Generally, we use a big O only for taking only worst time case. So it will already be optimized if we take worst time case and date. So there is also a mathematical way of calculating time complexity. Do you also want to learn that?
Mathematical in the sense we have some formula to calculate the time
Yeah,
complex.
yeah, yes.
Just you can show the overview. I have not personally seen that before.
So Atul, one thing,
Yes,
why, I mean, when we are calculating the time complexity, only
yeah,
the loops are being counted. Like, if, for example, if I have a 200 lines of a code in a function,
yeah.
so like, why do we calculate only the loops for time complexity?
Okay. Uh, so like the the code which we write here basically would be some like adding some operations only, right? Like if
Mhm.
we add something into another data structure or if we do any mathematical operations, something like that only. For calculating time complexity, we say that this will take order of one only, constant time, period of time.
Okay, for
If we,
for example, if it has a 200 lines of code
yeah,
and each gets executed only once, max once, so
yeah,
that means it's a order of one time complexity.
yeah, correct.
And if it has a 200 lines of code that gets executed, like for example, let's say in that 50 lines of code gets executed 10 times for
Uh,
10 number of inputs. Like if
okay, yeah,
so that means there, like the remaining 150 lines gets executed with order of one, but the the 50 lines of code that runs in a loop for the inputs, so there the complexity will increase.
uh, we calculate complexity of the complete code, not only for like for this for loop, but and for
So maximum it will
calculating,
be taken, no? Like
yeah, for complete,
maximum of all the complexities.
yes, yes, maximum.
Hmm.
So
And basically, this order of n calculates the worst case of the
yes, yes,
uh, execution. I mean, not worst case of the complexity of a piece of
first
code.
running time, yeah, you can,
Think
uh,
this calculation is based on order of n plus k, right? So we'll consider that k also like constant number of
uh,
lines code whatever we are having apart from loop.
that is what I'm feeling. That we consider the order of one only. If we have any operations or any inserts and deletion operation, mathematical operation, we that will take only order of one operation and complexity.
Okay.
And it is defined only for like a variable time. If any variable we define, then only we can define time complexity.
Hmm.
So here n
First,
is what?
input something like we can say that if we have a huge amount of data, that data we can say that that is and
Say
the
for
size
example,
of the
we
data.
have 1 million records and you have to
Yeah.
process on each record, then you will n will be like 1 million or
Yes.
1,000 like that. So say for example, you have to iterate over 10 times to achieve some functionality, then the order of n will be 10 into n, right? Or n
Order
to the
10
power.
into n with for like 10 into n is also we represent it as n only because
Hmm.
constant and 10 is constant
Kn
only.
is n, yeah.
Hmm. Okay.
Okay, I was showing this mass.
Atul, one more thing. So basically, learning the time complexity and how to calculate it helps me write code that executes faster. Is that correct?
Yeah.
Okay.
If we want to like exactly calculate the order, then
And
we use Master's theorem for that.
I
Yeah.
mean, in my understanding, like all these data structures are mainly to reduce the time complexity and reduce the space complexity. Space complexity is lesser priority, but only to reduce the time complexity, right?
Yeah.
yeah,
Correct.
based on application, we can say.
Yeah. I mean, any application you can see, you can, if you consider the
Hmm.
multiple data structures concepts has come in a different use cases to implement some kind of methodologies. Using that, the aim of implementation of a data structure is to reduce the time complexity that it takes to execute the piece of code.
Yeah, mainly in web application we can say that, but if you go in another domain like IoT or embedded system or based on, I mean, those applications in those space complexity matters a lot. So they can compromise on time complexity, but they have to be they cannot increase the memory size of a certain board, right? So they
Hmm.
have to adjust the same functionality in like kbs or bytes of
Hmm.
code. So
Hmm.
there the space complexity is much needed. They have to optimize on that side.
Hmm. Okay. Yeah.
I have one more question. Uh, there are so is it true that time complexity is something you can calculate only for synchronous codes? Like, what about asynchronous codes? Like no Node.js and all. They don't execute line by line, no.
Hmm. Yeah.
So in that case, how do you calculate time complexity? Or is that concept not valid for such type of execution?
Uh, that we need to check, but we can calculate like the asynchronous part. Uh, that part we can separately calculate
Hmm.
the time complexity of that part.
Okay. Okay, fine.
I mean, what's your question, Sarang?
No, I wanted to understand this time complexity, if it is for only synchronous code or async code also, it is applicable. You understood?
So, like,
Sync
asynchronous code in the sense?
see, no, normally when we write code, it is executed line by line, like one line after the
Sequentially.
other.
Sequentially.
Sequentially, yes.
Yeah. Okay.
So
I
async non-sequentially also there are languages which execute code. So in that case, is that concept invalid or it is in a different way interpreted? That's what I wanted to know.
I
Yeah,
don't think it's
like that.
invalid, but if you take that asynchronous code, if you want to calculate the time complexity of that asynchronous code, then
Hmm.
there you have to calculate. So basically you need to get the data set, or on which data set you want to calculate this time complexity.
Okay,
Hmm.
so I'll tell you like if this is complete code from here to here, uh, if if it is synchronous or asynchronous, like the time complexity will be calculated like this only. For this piece of code, the time complexity is order of order
Hmm.
of three, and which will be n. For this, it will be order of n, and this will be n. This will be n square. And if we take total time complexity, the n plus n plus n plus n square, we'll say that the overall time complexity is n square. That
Okay.
will be also true for asynchronous.
No,
Okay.
yeah, I think this is correct, Atul. But Sarang's question is, now you can include one more block between anywhere, and that block will not, I mean, the next block to that block will not depend on the execution of that block. So that block will execute behind the back. I mean, in
Hmm.
background, you can assume.
No,
So
the
the
thing,
total complexity will not depend on that block, right?
no,
No,
Pankaj,
no, if
we
you
are
add any
combining.
another block,
Which is running
if
asynchronously on behind the
No,
background,
no,
kind of.
yeah,
we are combining two things, no? Like I think Atul has explained firstly, like
uh,
execution time is not dependent on the time complexity. So
uh,
asynchronous code will help in reducing the uh, execution time by executing
mm,
it parallelly, right?
yes,
Ah,
So, but there the execution time will be lesser, but the complexity is still same. You are writing a piece of code that
yes.
has to be executed.
okay.
It like the if we take different piece of code, we can calculate time complexity by taking complexity of this plus complexity of this plus complexity of this. If we add any async operation also, we'll add that complexity, and we'll see overall the maximum what will be the complexity, and that will say overall the time complexity. Here for complete this code, n square is maximum, so we'll say from here to here. If that is our overall code, then the time complexity is order of n square.
Hmm. Okay.
Got it, got it.
So, uh, this time complexity will be
Mhm.
calculated at function level or at repository level or at class level? What level it will be calculated?
Okay. We can calculate like some basic also, like if we want to calculate any part, like complexity of any part also, like this only. We can calculate that separate part. If only this single line of code is there, you can say that is order of one, that it's time complexity is order of one. And
Mm-hmm.
if we take complete loop, it will be order of n here. Then if we take more piece of code there, we can basically add all those time complexities, and we can calculate overall time complexity. Can be can go up to deposit repository level, we cannot say, but it can go up to like file level or a function level.
Mm-hmm. I mean, basically the purpose, I mean, the feature that you're working are,
Yeah,
yeah.
that feature we can see.
Mm-hmm.
For like mathematically writing the relation, we use master theorem, that is for sim for simple relations like this, we can say that it is taking order of n. It is also n plus 5, which is n here, n into n. If we like concatenate different loops into each other, then the time complexity will be multiplied with each other. If they are k nested loops, then time complexity will be n into n into n k times. For here, we have two loops which go to till n, and it is going one by one only. So the time complexity is n into n. If it changes here, like it becomes one I plus I into something, here j into something. It doesn't increase it one by one. Then the complexity will also change. Uh, so basically, it complexity shows how many times that piece of code will execute. Did you understand that?
Mm.
Okay.
So, for example, there
Mm.
I is equal to 1, I less than 10, and I plus
Yeah.
plus. J is equal
Uh,
to 1, J less than 10, J into
mhm.
3 is there.
Yeah.
So, in this case, like it will be n into n by 3, is it?
And into n by 3. Yeah. Uh, the piece of code will run n by 3 times. Yeah, correct.
So, order will be n square by 3,
Which is n square only.
n square only. Okay. Mm-hmm.
For uh, that master theorem I was showing, basically for recursion, we will have many difficulties. We cannot simply tell the time complexity of that. So that if we want to write the relation of the time complexity, there is a theorem, Master's theorem. For so if there is a recursion here, recursive function here, only one function is called, then we can simply tell like it will run n times only, because all other operations are taking one order of one, because they are only simply one line statement, return statement. So we take that order of one only, and only one time this function is called. It will run only n times. So we tell this function has a time complexity of n. But if that function is called two times here, same function is called two times, that will not be like easy to imagine. So if you want to mathematically calculate, then there is master's theorem here, which defines the relation between time complexity and the input and other constants. So how do you basically calculate total order? Here it is shown. For first time it will run one time, then these two will be called. Then again those two are shown here. First something is there, it will call two times. Then again that will call two times here, here, here and here. Then that will also call two times. Same two times, two
This
times.
piece of code, does it call two times or always the first will be executed? No,
No, this function will call this function, then this function two times. That function is called
but
with n
this
minus one
function
parameter.
only after it responds it back, it will call the next piece of code. No,
No, this will run separately. This will run separately.
it doesn't wait for responses.
Like it, this will be completed, then this will
Correct.
run.
But that
Yeah,
will
correct.
never get completed. No, the first one.
No, we have defined a return statement here. Na? If n is equal to 1, it
For
will
five,
right.
for example, 5, if we take,
Yes.
so first left side, left side, left side will come.
Yeah, correct. Left side, left side, left side will come till 1, then it will return, then it will go here, right side, then here. This way it will go.
Okay.
So roughly for calculating the time complexity, we'll say first it is called one times, then two times, then four times, then here to the power 5 to the power 6 something times. Last will be to the power n minus 1 time. If we add all those things, we'll get to the power n minus 1, which is order of the power n. If you understand. You got this one.
Oh, I didn't understand. Can you explain again? How did you
Okay,
say that
like
it is coming like this?
uh, so I told you earlier, na, like for calculating complete time complexity, if this is one piece of code, then we calculate this its time complexity, then this, then we add all of those complexities, and the resulting will be the overall time complexity.
Yes.
So similarly for this, there is only one return statement here. So we'll say it will take only order of one time, but
Hmm.
other statements, this and this are these two things are called.
Hmm.
And these two things, how many times it will run? It will run. Okay, wait. So from first point, two functions are called. That two function in return call two more functions. It will call
Hmm.
two more functions. Then for calculating overall with time complexity, we will add each time complexities. So for this piece of code, it will be like one piece of for this level we will have one execution code execution. For this we'll have same code executed two times, here four times, and here
Hmm.
16 times. Then it will be like till to power n minus 1
Okay.
last leaf node. And if we add all of that, we'll get 2 power n minus 1, which is minus 1 we can neglect. Then it will be order of 2 power n for this thing.
Okay.
Yeah, so these are the basic type complexity that we'll see in an algorithm generally. Order of n. which is constant time, like any print statement, mathematical operations, and delete, add operation will say this is order of one. Logarithmic time. Uh, okay. Logarithmic time, you can say like if you run any piece of code and that code will run in how do I say? Okay, it will generate a series of logarithm. Like here it is generated a series. Then if any piece of code generated a series of logarithm, it is 1 by 2 squares, like it will get half till 0. Then it will say it is order of log n, like a binary search. Okay. In binary search, uh, we take first divide the thing into half. If it is a if we say this is one, complete sensing is one, and in binary search we divide the thing in half 1 by 2. Then the search space is like we uh, taken only half of the sample space of the overall, and we'll search in here. And again, we'll take half. I'll explain binary search later. I'm just simply telling you. So it will again become half, then again half. If if we add complete these things till 0, that will become a series of logarithm. So it is also one of famous time complexities used in algorithms. Square root, it will go till a square root of any number, and then linear. If if like the for loop we have shown here, this is a linear time complexity, and quadratic time complexity. If we have two loops nested in each other, then it will have n square, then three loops, then n cubed. 2 to the power n we have seen here in recursive function. If it's called to function like this, we'll have 2 to the power n factorial. If we generate all subsets, we'll see this time complexity n factorial. Yeah.
At what situations this n log n will be there?
N log n, okay. N log n, like if there is a n loop like this, and in this piece of code, rather than having single line of code, let's say we'll have binary search code inside here. So for every time it will have log n. First time it will code will log n, then second time log n till n times. So in like the nested loops, we multiply here n and here also n. Here also will multiply the time complexities if they are nested. If this piece of code is binary search, that's time complexity is log n, and it will run n times. So total will be n into log n. Got it?
Okay, yeah.
Yeah.
Like any other examples than binary search?
Log n.
Yeah.
Yeah. Okay. Explain through numbers only. Like log, we will have to generate log series somehow. Like if uh,
What do you mean by log series?
okay. So like if you have read in mathematics, like everything, tan, sine, everything has expansions there, na? E for x also have expansions. Log expansions. This series, if you write mathematically, like cos, sine will have its expansion, cos will have expansion,
Okay.
log, similarly log will have expansion.
Got it.
If we want to calculate mathematically, this would be like if you get complexities in this series, we can say that is log order of log x or exponential x.
think maybe we'll stop today.
Yeah.
So
Can
the
talk
time
to the
complexity is over now, right? Or anything left today?
we can see some actual like codes and analyze. Rest is done.
I mean, examples we can see tomorrow.
Okay.
Yeah. Okay.
Okay.
Yes.
Okay.
So I'll stop sharing.